All right, I guess we'll get started. I usually start about 2 minutes in, especially on the first day, right? Because nobody seems to be able to find the room. So we'll just give, we'll probably see people straggling in. There's supposed to be 40 people in this class, about 27 of you here. Now that could be because it's 7 o'clock on a Thursday, which is pretty rough for the most part. But yeah, so that's the case. We have a couple of slide decks to go through. These are the only 2 slide decks that you'll ever have in this class. I mean, you're programmers, right? You want to program. So that's what we're going to do. We're going to program. I don't want to just do lectures because that's boring for me and it's boring for you. But there's 2 slide decks that we have to get through. The first one will be basically introductions and expectations and that kind of thing. And then the second one will introduce JavaScript to you and just some history about it. And then that's it. And then we'll get right into code after that. Today we're going to actually talk about variables and conditionals, which shouldn't be new, right? Most of you know what variables and conditionals are, if not all of you. But, you know, there's syntactical differences with JavaScript, especially considering JavaScript is a loose language as opposed to a strict language like Java. Just out of curiosity, how many of you actually coded in JavaScript before? So, yeah, a few of you. Yeah, that's not too bad. We're going to take it really slow. I taught it last semester, and I learned kind of the hard lesson that when you come from strict languages and you go to a loose language like JavaScript, which is asynchronous and it's got its like little idiosyncrasies inside of it, it definitely makes sense to take it slower. You guys will have a better chance of being successful in it if we take it a little slower. All right, so let's kill one of these slide decks off. I'll just hit play on it. If I can find the stupid play button. There it is. Yay! All right, so this is Comp 1073, Intro to Client-Side Scripting, which we'll be doing JavaScript. That being said, there are other client-side scripting languages like VBScript. Some people consider HTML and CSS to be client-side scripting as well. But this is definitely a JavaScript class, so if you're like, I didn't know I was taking JavaScript, I wasn't supposed to be here, then feel free to leave. Otherwise, stick around. I'm Sean, not professor. Not sir, not instructor, just call me Sean, yes, please. I prefer Sean. I've been programming for about 17 years. Professionally though, like a lot of that was hobbying and stuff like that, but professionally I've been programming for almost 6 years now actually, working in the industry. Let's move to the next slide. I currently work at Mintent, which is here in Barrie. They used to be known as G-Shift. We're like an SEO marketing company, only we build the application for SEO marketers to use. So we deal with like terabytes of data scraping from Google and stuff like that. And a lot of AWS, and our platform's Ruby, Python, Go, and a whole bunch of other languages as well. So I have a lot of experience with programming, mostly web-based languages, though I do have some strict language experience. I teach C++ here as well, and I went to UOIT for game development and did C++. I didn't stay there though. I only went for about 2 semesters and then I was done with it. Turns out you really need to know a lot of math to do game development, like really complex math, and I wasn't expecting that, nor was I ready for it. I went to Georgian College just like you guys. I completed the WBAN course back in 2014. WBAN was web design and animation. We did animation with Flash. You know, the language that nobody uses anymore because it's completely dead. But yeah, we did animation. And then I moved on to G-Shift, left G-Shift, went to Fireside, did some freelance, went to university, came back out, and now I work at Mintent. That's me. This is the game that we developed in university. You can't download it on Steam, and it's crap. I might show it to you sometime. I'll bring it in. I'll have to bring in a Windows machine because you actually need a half-decent video card because our optimization sucks. But yeah, I can always give it a show though. Expectations. I'm sure you've heard this already. You guys are what, second semester? Or second year?
Second year.
Second year, so you're like third semester then. Okay, so I'm sure you've gotten this idea. Be here, you know. I do record my lessons though. So if you're going to miss a class, that's totally fine. That being said though, I tend to do quizzes and labs in class, and there has been occasions where I'm overtired, I shut the laptop, I forget to hit save, and the recording doesn't get saved. And I don't go back and re-record because it's I don't get paid for that. So I recommend being here. Not to mention it. You know what? You get your money's worth when you're here because you can interact with me, you can interact with your other peers. You get a little bit of like insight stuff because I tend to pause when we're on break, and sometimes conversations come up and that gets missed in the recording. So it's definitely worth your money and your while to be here. Be on time. That being said, you can be 2 minutes late. I will always start class 2 minutes in. Just the way I do it, right? Show dedication, prove your worth to your value to your colleagues. Yada, 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 blah, blah, blah. Cool. Participate. Nothing worse than me standing up here talking for 3 hours straight. That sucks. Like, I really like back and forth. I really like to be challenged. I like to, engage. Questions, anything, please. Yeah, I'm an open book. I love to talk. Academic misconduct. I'm sure you guys know. Don't cheat. Don't plagiarize. Don't infringe copyright trademarks because it's super embarrassing for everybody. I'm not a confrontational person, but I will challenge you if you cheat. That's just the way it is. And I zero out everything. If I find something that's cheated, and it's always obvious. People don't think it's obvious, but it is. It's like blatantly obvious. I just zero it out. It's usually what happens. Why I care if you cheat? Because I work in the industry. I'm not a full-time teacher. I actually have like a 40-hour-a-week job. And I don't want my industry oversaturated with people who can't do the job, cheapening the labor market. So to me, no, don't cheat. Due dates and submissions. There's weekly labs, though if you're here or if you're at home following online on YouTube, you will complete the lab because the idea is the lab will be interactive during the class. You'll see when we do variables and conditions later on in this class, you'll see what I mean. Quizzes are by the end of the next day. That might seem like it's extreme, but there's only ever about maybe 10, 15 questions on the quiz. You get 2 attempts at that quiz. You can work in pairs. You can work in, I don't care if you all collaborate on the quiz and figure it out. That's totally fine. The whole idea of the quiz, though, is so I can kind of see how you're progressing through the course. This worked really well last semester because I was able to refine my course and make it a little better for you guys. So you get like version 2.0 of this course. The quizzes are very simple, but they will close out by the end of tomorrow. So 11:59 tomorrow, the quiz disappears. Opens up in an hour in class. So if you're like, I know JavaScript backwards and forwards, at 8 o'clock tonight, you can start your quiz. You can take it if you want to. Assignments, I do 1 per term. That's it, just 1. I'm not big on heavy assignments and labs and stuff like that. 1, because it makes a lot of marking for me. And then 2, you guys have enough classes. How many programming classes do you have this semester? 2? 3? Oh, 3? Are you guys doing Internet of Things this class too? Or this semester? No?
No, we had that first semester.
Oh, you had that first semester? All right, but either way, you still have enough workload. You have gen eds this semester? Yeah, so it's right there. I don't know what it is with gen ed teachers. They're like masochists. They just want to give you tons of homework for a completely useless subject. But yeah. But I'm not going to give you tons. The labs and the quizzes will allow me to gauge what you're doing. And then the assignments, they should be able to kind of show how you can stand out against your peers. So there'll be 2 of those, plus a midterm and a final. Extensions, I do offer them where I feel necessary. Don't ask me for an extension the day before, because it will always be a no. Make sure you ask me for an extension a couple of days before, 3 days before kind of thing. And I also want to see your progress. If there's no progress, there's no extension. You have to at least make an attempt. Because generally, I'm going to give you your assignment 1 about 4 weeks before it's due. In all honesty, it should take you 2 to 3 hours to complete it. So if you don't get it done in 4 weeks and you're asking me for an extension the night before, yeah, no. Sorry, dude, no. I give grace periods sometimes. If I find that enough people are having difficulty with the assignment, then I will make the extension. I did that last semester. I extended it twice, and we wound up into the second term before it was all completed and handed in. Submissions. Submissions must be submitted to Blackboard, Dropbox, depending on the size solution. We're not going to do anything big enough that requires Dropbox. Multi-file submissions must be compressed. Ensure you obey the submission request in the lab assignment instructions. All labs are just take your main JS file and upload it to Blackboard. Every single lab will be like that. So please don't compress files for that. It makes my life a lot easier if I can just copy and paste your content into my tester and let it run. Agenda for the average class. We'll be reviewing the last class, learning outcome, introduce today's topic, lecture interactive demo, which will be every class. I do 15-minute breaks that gives you time to get food. Is anything even open now in the school? Yeah, it's all closed. I mean, it gives you 15 minutes to go relax for a minute, whatever. And then, and then we'll do the lab quiz. If there's any time left over, you can work on the lab quiz. Sometimes we'll end early. If we end early, I stick around all the way through. So if you need support for your labs, quizzes, assignments, or even maybe assignments that you have in other classes, I might be able to assist you with those. Feel free to take advantage of me because I won't leave till 8:50. So, or no, 9:50. My God, this goes till 10. That's a late night. Yeah. All right, communicating with me. Best way to communicate with me is Slack. There's an invite link under the resources inside Blackboard. It's 100% the fastest way to reach me because it goes to my phone, it goes to my tablet, to my Mac, to my work computer, and I usually reply relatively fast unless I'm in a meeting or something like that, then I won't, but it is definitely quicker than email. Email I tend to check like once a day. Yeah, I would say Slack. Slack is 100% the fastest. If you are going to email me though, please make sure you tell me what class you're in, because there's like 40 of you, there's 40 of the other students, and I don't do like the whole meet and greet intro thing because I have a crappy memory. So it takes me quite a while to put names to faces and stuff, so make sure you tell me what class you're in. Otherwise, I'm not going to know who you are. You give me a summary of what's wrong, what you've done to fix it. Make sure you've at least made an attempt to fix it. And then a zip of whatever current progress you're at, and then I'll see what I can do to help you. Syllabus. All right. One stupid slide deck down. One more stupid slide deck to go. All right. Meeting time and location, obviously, Thursday, 7 p.m., otherwise you wouldn't be here. Course description, like I said, it's client-side scripting, which is basically about implementing interactive behavior in the browsers. Obviously, JavaScript can go much further than that. There's server-side JavaScript, which, if you guys are in this semester, you'd be the server-side JavaScript in the fall, which you might get me for. It's hard to say, which is Node and React and stuff like that. This is not an HTML or CSS class. Did anybody in here not get HTML and CSS in like your first semester? Yeah, that's what I thought. So I don't teach HTML and CSS. I can do it. That being said, there's not going to be any marks for your style and design because I don't care. We're literally just going to attach Bootstrap to everything and let Bootstrap do most of the work for us. So there's two resources. This GitHub link is wrong. I will post the correct one in the resources for you. But all of our stuff will be going up to that GitHub link. There's my YouTube channel, which I would recommend subscribing to. And then our textbook, which is 100% free because it's the Mozilla Developer Network, right? So use that as your resource when you're trying to learn JavaScript outside of this class, all right? Sometimes I will reference it, and I'll post the reference link inside our notes. Yeah. So office hours, you can find me here at the school. I finish work at 4:30. I come here, I eat dinner, and then I come here. So I'm usually here by 5. And class doesn't start till 7. So I have like 2 hours that I'm here. I'm usually just sitting out there playing my Switch until you guys show up. So yeah, so you got 2 hours before class on Thursdays. If you need to reach me on Tuesdays, that also works. I teach at 6. I get here at about 5 as well, so you can always grab me between that hour. Outside of that, it's Slack or email because I live in Aurelia and I'm not going to drive to Barrie. So yeah, so outside of that, just make sure you contact me via Slack. It seems to have worked before. I've never had anybody that's needed me outside of that. All right, evaluations. There's 10 labs. There's actually 12 labs. You get 2 as a bonus, so you can skip 2 if you want. There's 10 quizzes. There's actually 12 quizzes. Again, you have 2 kind of a grace. There's 2 assignments. Notice the marks on the assignments are 20% each. They're quite heavy. And the tests in this course, I was astounded at how heavy they are, but that's the college that's set those. They're 20% apiece, so they're quite hefty. My tests tend to be long. You get 3 hours for the test, and it usually takes the average student the full 3 hours to complete the test. There's a lot of information. They're always open book, open internet, but don't let that fool you. That doesn't make them easier. Because if you don't know what you're looking for, it makes it 10 times harder. So I definitely recommend studying to make allow yourself to be more successful. The breakdown, this may change. It shouldn't change, but it may. Today we're doing variables and conditions. Next week's arrays, loops, and array iterations. Then we're getting into functions, making our own, and using library functions that are built into JavaScript. We'll talk about object literals and constructors, because object-oriented programming in JavaScript is not the same as object-oriented programming in Java. It is very different. We'll talk about the object prototype in week 5. And then we'll do the DOM part 1 in week 6. You may think this is kind of a weird structure. If you come from JavaScript, you're like, well, how come we're not learning the DOM first? I found from last semester when I taught this that this order definitely makes a lot more sense than the way I did it last semester. Last semester I started with DOM. It was just super confusing, and I wound up having to go right back to basics. So we're going to start at the basics and build ourselves up to the last class where we'll be doing client-based storage solutions, which is local storage and cookies. Which is how you maintain state in the client, or in the browser, I'll say. That's basically it. That's the syllabus. Cool. That's one slide deck, one syllabus, and a 718. Any questions? Yeah.
Yeah, I was going to ask, when are assignments going to be scheduled for? 'Cause I don't really see them.
Yeah, I haven't posted when the assignments are going to start. I don't do the same assignments as I do each semester, because otherwise it just leads to people copying the original assignment. So I'm trying to figure out what I want to do. I like to get like a 2-week feel for the class first to see whether or not I want to do an open-ended assignment where you guys submit an assignment based on your own idea. So I give you a logic problem, you complete the logic problem, or I give you a step-by-step-by-step assignment. So there's like kind of 2 possibilities. That being said, even if I do a step-by-step assignment and you're like, you know what, I want to learn React, and I want to take the time that I'm doing this assignment to do that, and then hand it in and have you grade it, I'll do that. I marked some guy's React assignment last year. 4 times I marked React assignments for 2 different people. So yeah, totally do that. I'm open to that. Just make sure I know. But yeah, cool. Any other questions? No? Cool. All right, let's get on to the next one, and then we'll take a nice break. Bam. Introducing JavaScript. Asynchronicity is a tough word to spell. JavaScript is asynchronous. That means 2 processes can run simultaneously. Well, no, sorry, that's parallelism. It means it doesn't wait. It doesn't wait around before it completes other operations. It just continues through. Don't worry if you don't know what I'm talking about. Over the next few weeks, you'll become an asynchronous master. JavaScript is not Java, but it is inspired by it. The syntax has some similarities. Like, for example, it is dot syntax. So when you're accessing methods or properties, you're using dot syntax to do that. So that part's familiar. But that's kind of where it ends. It was created by this fella, Brendan Eich. He worked for Netscape. Anybody in here old enough to remember Netscape? Some of you? Yeah? He co-founded Mozilla, right? The guys who make Firefox, the guys who made the textbook, Mozilla Developer Network. He created JavaScript, which he based it on the Java syntax. That's why there's some similarities. He wrote the prototype in 10 days. That's pretty fast. And it was originally called LiveScript. And after that, like a few other companies kind of based their own languages off of. Microsoft had their own version of JavaScript that they used to call JScript, but that kind of died along with other things that Microsoft invents dies. JavaScript is a loose language. That means it's not strict like the languages you guys are used to working with. It's loosely typed. Basically, it casts data types automatically. It's known as implicit casting, which means it evaluates the value of what your data is and then defines the data type at interpretation. So if you have a string, it's like, cool, that's a string. And then you're like, no, I'm not going to make it a 5. Then it's like, okay, cool, well, that's now a 5. JavaScript is very, very loose. There are ways to make it more rigid. There's a transpiling language known as TypeScript. Sorry, pre-processing language known as TypeScript. TypeScript layers onto JavaScript and allows you to create data types inside JavaScript. We won't be doing TypeScript in this class, but you may do it in the advanced JavaScript frameworks class. JavaScript can be written directly in the browser using the developer tools that are built into Firefox, into Safari, into Chrome. I generally use Chrome. That tends to be my go-to browser. You are welcome to use whatever you want, except for Internet Explorer. Do not use Internet Explorer. We're going to be using some ES6 stuff and a few little ES5 things. Internet Explorer is good stuff. Okay? Edge, yeah, you can use Edge if you want to. I'm going to make fun of you, but you can use Edge if you want to. Otherwise, Chrome, Firefox, they tend to be the easiest ones for most people. All right, so it can be written in the browser. However, they all have different rendering engines for JavaScript. In Chrome, it's V8. It's written entirely in C++. It used to power Node.js and MongoDB. It doesn't anymore. It's existed since 2008. Compiles directly to machine code, making it like stupid fast, right? Firefox's is SpiderMonkey, which is written in C and C++. First JavaScript engine that existed. It powers the GNOME desktop, which is a Linux distribution desktop. It powers MongoDB as of version 3.2, right? And it's also super, super fast. Safari Nitro, written by Apple for Mac OS application, currently compiles directly into native machine code for Mac. But which one is faster? At the end of the day, doesn't matter. Because love them or hate them, the user is the most important result, and we tend to hate them because they always break our stuff. They define your accessibility, right? They define how your controls are going to work, what kind of interaction, what kind of input you're going to get. They establish your audience. They declare how popular your particular thing is, right? Like when a Kardashian turns around and says, I really love Snapchat. Snapchat goes skyrocketing through the roof. And then when they're like, I hate Snapchat, then it like nosedives, right? They define our popularity. They determine usability and they control environment. But the big thing is they make sure you get paid, right? Without the user, there's no paycheck at the end of the day. So love them or hate them, you got to keep them around. JavaScript gives us client-side powers. That's how you spell dun-da-da-da. They allow us to store information, right, using local storage, cookies, or posting and getting from APIs. They unreliably maintain state because we're doing client-side scripting and not server-side scripting. We don't control what the user does with their browser. If they don't want to store cookies, granted their surfing life is going to suck, but if they don't want to store cookies, they don't have to. So you can't reliably maintain state, but you do have options with like local storage and cookies to try to get close to maintaining state. We can manipulate the DOM. The DOM is the document object model. It's your web page, essentially. Allow us to target text and change its color and animate it and make, fluffy bunnies and whatever else we want to do on that page. We can control that with JavaScript. We control the vertical and the horizontal. Boop. What? Move. There we go. We can respond to user events. Clicks, double clicks, changing a field, moving your mouse, all those type of things, all those type of physical interactions, including events that aren't even necessarily physical, like custom events that we want to call or services that have been triggered. We can respond to those events. We can use browser APIs, such as the built-in standard JS library that comes with our browser, and they're not always the same, right? Chrome's usually cutting edge. Like right now, you can use ES 2018 directly inside Chrome, but it might blow up on your face when you try to use it in Firefox. But for the most part, if they're following a standard, we have access to that standard library, ES whatever, geolocation, right? So you can actually geolocate your users. They have to confirm and authenticate that. But text-to-speech, which we might take a look at, that's pretty cool. Generating SVG, 2D, and 3D graphics directly through Canvas or WebGL. Audio-video control as well, and notifications using the browser services system. We also have access to third-party APIs such as Google Maps, social media, merchant APIs like, Moneris, PayPal, Stripe, all those guys, Square. Shipping APIs, right? Like Canada Post, FedEx, whatever. CDNs. CDNs stand for Content Delivery Networks. We're going to be using a few of those. One really cool one, I'm not sure if any of you are interested in like video game development, whatever, but there's a JavaScript library called Phaser, which allows you to make 2D development games, and it's like really simple. It takes care of all the math for you, so you don't have to learn collision detection and all that. You just got to make some pretty sprites and put them on the screen and add a little bit of logic, and off you go. There's also P5.js for those of you that are a little bit more hardcore and want a half-decent math library. There's jQuery and there's Bootstrap. We're not going to learn jQuery in this class. Right off the bat. No way. ES6 is replacing jQuery. We're slowly starting to strip jQuery out of our application at work because it's just, there's no reason for it when ES6 is just as fast as development. So that being said, if you want to know jQuery, though, it's not hard to pick up. It's pretty easy to learn, but I definitely recommend. It's kind of like learn vanilla JavaScript, right? Learn to drive a Mack truck before you learn to drive a little Smart 4.2 car, because then driving the Smart 4.2 is much, much easier, right? So if you learn vanilla JavaScript, you learn the foundation, and it gives you a lot more control and a lot more power before you start working with frameworks like jQuery. Oh, I totally missed the last slide. Sorry. Didn't even read it out loud. JavaScript is an interpretive, single-threaded, event-based, asynchronous, non-blocking, callback-driven language. That's a mouthful, but that is what it is. Interpretive, as opposed to the language you guys have worked in, which is compiled, right? You guys have to compile your languages. JavaScript, it's interpretive, means it starts at line 1 and slowly interprets through the script, right? Single-threaded, have you guys done any multi-threading apps? No? All right, well, single-threaded, basically it follows along one thread process. Event-based, though, so when a event is called, it gets added to the event queue, and then it slowly goes through the event queue, but it doesn't stall. It's asynchronous. It will move on to other things while other things are taking up time. So while you're doing an API call, it's not going to wait for the response. It's going to move on and do other things, which is the reason why we have callbacks, which can turn into a lot of confusion. That's why we take this class very, very slow. All right. Cool. Any questions? No, none of that is going to wind up on a test, just so you're aware. Cool. It's only 7:30. Wow, I powered through that one. Okay, let's talk about IDEs. You guys, the last class, they had Jessica Gilfillan. Did you guys have Jessica Gilfillan for PHP?
Yeah.
Yeah, so you guys downloaded Sublime?
Yeah.
Sublime's what I use, right? I kind of tend to love it. So I use it quite heavily, and a lot of I'll even like spit out like little shortcuts in Sublime, like multi-cursors and multi-copy paste, and how to move a line up and down, how to delete a direct line, stuff like that, and I'll show you those little tricks. Now, granted, a lot of those tricks also work in Visual Studio Code. If you're running Windows, Visual Studio Code's pretty cool because you can do Java in it, you can do C++ in it, you can do a lot of things in it, but it's a lot more lightweight than Visual Studio, right? So it's not like 6 gigs of download stuff. It's pretty small, actually. I think it's less than a gig. And you can download different packages just like you do with Sublime and, give it a little bit more oomph. So I definitely recommend Visual Studio Code. Sublime. US students have access to WebStorm for free. WebStorm is normally a paid-for app by JetBrains. WebStorm's pretty good. There's some issues with it, though. I'm not a huge fan of it. I really recommend if you are going to use it, don't use the built-in server. The built-in server tends to cause a lot of issues. And I've had some issues in the past with its linting, where I'll show an example and then the linter in WebStorm says it's incorrect, but it's not. So things like that. If you want to go really hardcore, Notepad++ is about as rudimentary as you can get, short of using Notepad by itself, right? With no syntax highlighted, that's super hardcore. But Notepad++ isn't too bad. It's pretty lightweight. It's open source, so it's completely free. And then last but not least, this isn't so much an IDE. It is, but it's not really an IDE that you would use in class. This is CodePen. If you're working together, one of the assignments will be a group project, but if you're working together and you want to collaborate with each other, CodePen's fantastic because you can actually collaborate in real time with each other, which is pretty cool. That being said, though, Visual Studio Code has an extension for it that allows you to you guys have used Google Docs, right? You know how like two people can connect to a Google Doc and type at the same time?
Yeah.
Visual Studio Code has an extension that does that to your IDE.
Actually.
Yeah, so that you can like interactively at the same time code at the same time.
Because I use Microsoft Code.
Visual Studio Code? Yeah, there's an extension that allows for connecting to multiple Visual Studio Code environments and all connecting back and forth. Yeah, you have to look for it. I think it's called Collaborative. It's like a collaborative extension or something like that. Yeah, it's pretty cool. Yeah, so anyways, please get an IDE if you don't have it, or open up an IDE. I mean, I think NetBeans works for JavaScript as well. I think Eclipse does too, so if you really want to use those, you know, janky old baby boomer kind of IDEs, go for it. All right, if you go to Georgian, your courses, we're client-side scripting, 19W, so winter 19. You're going to see some folders on the left-hand side. There's a folder called Resources. That's where you'll find the Slack invite link. If you want to click that and join Slack, like I said, it is the quickest and easiest way to get a hold of me. The other class is also clicking and join it. Not to mention, I've had 2 semesters before that have clicked and join it. So if you ever ask a question in it, it's getting pretty good. Like sometimes it's not always me that responds. You get other people who know it and respond pretty quick. So yeah, it's definitely worthwhile. Course information, where you'll find your syllabus. The syllabus won't likely change on there, but it's there. I'm sure people have told you when you take a class, always download the course outline, always download the syllabus. Yeah, especially if you ever want to go to like university after this and take a bridge program, you need all of those in order to like say, this is what I learned. Weekly learning is where you'll find our classes. They open up at 7. Actually, I think they open up about an hour before. So the course materials should be there for about an hour before. The lab and the module quiz open up at 8. So an hour into class, and they open up. And that'll be the way it is for every class. What else is there? I think that's it. Other than that, there's a labs folder where you'll find the lab submissions, though I do link to the lab submissions under the weekly learning, and the quiz where you can actually take your quizzes. All right? We're obviously going to start in weekly learning. Click the little folder link, and you'll see the web link for Module 1 for Week 1. That's going to take you to GitHub. And you see the wonderful little clone or download. We're just going to download it. We're not going to clone it. So just click clone or download. Download a zip. To click with more dedication, I guess. I'm going to save that to my desktop. Once it's saved, go ahead and unzip it. And you can get rid of whatever the zip file is. And inside that folder, you're going to find a folder called Module 1. And that is what I want you to open up in your IDE. There's a few different ways you can do that. You can just drag and drop if you're in Sublime. Otherwise, you can go to File, Open, navigate to wherever you put the file. Click on the Module 1 folder. Don't drill into it, though, because we're not going to open just one file. We're going to open up the whole project folder. And click Open. And if you did that correctly, you should see 4 files in an Assets folder on the left-hand side. These lessons are pretty cool because the labs are actually embedded into the lesson. So as we go through the class, we'll be working in a main.js file, and you'll be completing each of the steps in the main.js file. When we're done, the class, you just take that main.js file and submit it to your lab, and that's it. You're done. You're completed to go. The other cool thing about these is they self-evaluate. So as you complete a question, it will tell you if it's right or wrong, essentially, right off the bat. All right? So that kind of makes it a little neat because then if you get stuck, you can easily see that you're stuck. Makes life a little simple. The other thing we're going to do, open up a internet browser tab, whatever type of browser you choose to work with, just not Internet Explorer, please. All right, and you want to open up that index.html file in there. Now I'm going to use something a little bit different, but you can go to, I'll show you how to do it. You go to File, Open File, inside Chrome or whatever it is. Navigate to wherever you downloaded those things. Go to your Module 1 folder, and it's the index.html file that you want to open up. All right. And if you open it up and everything is good, you should see this with the wonderful styling. This is about the extent of my design capabilities. I can't even take all the credit. Most of it's Bootstrap. So. I know you guys are so stoked right now. Just like, yeah. If you weren't so freaking tired. What time did you guys start class today?
I got here from 11.
11 o'clock? Yeah, that makes a long day.
And I come from Yuma.
So you're not leaving either. You're stuck here all day. Yeah, that sucks. All right. Cool. We have a little bit of time, so I'm going to show you a couple of things just before we actually move through the lesson. I'm going to give you your first break because it's kind of a lot to deal with all at once, and we just did a whole whack of stuff. But one thing I wanted to show you is how to open up the developer tools inside your browser. Okay? Now, if you're working with Chrome, it's very, very simple. You can hit, if you're in Windows, you can hit F12 on your keyboard. You might have to hit the FN button and then F12 if you've removed, like, done something funky with your function keys. And you should see this pop up at the bottom for you, which is your console. If it doesn't, you might have to click the tab that says console. Now, I'm pretty sure F12 also works inside Firefox. I'm not sure if it starts right directly in the console. I can't remember. If you're on a Mac, it's Command-Alt-J. Command-Alt-J will open up your console for you, and it should start directly in the console window. Now, your console window may open at the bottom, or it may open on the side. It may open undocked. It just depends on how it is. If you want to control where it opens, these three little dots that are here on the right-hand side, if you click them, you see these four icons. The first icon undocks the console and makes it basically its own window, right? Which can be very handy when you're trying to see everything in one window and develop and look at the console for debugging in the other window. You can dock it to the left. You can dock it to the right. Sounds like a song. You can dock it to the bottom. All right? These errors in here, when we're done, they'll all be gone. Okay? I wrote those errors, by the way. Those are not standard JavaScript errors. Cool. That took all of like 3 seconds. Yeah, so why don't we take a small 15-minute break? Allow you guys to, I know I need a drink. It's getting very dry in here. Get a drink, maybe get some food from a vending machine, leave campus, go get food from McDonald's, whatever. It's only 15 minutes. And then we'll get into variables and conditionals. And yeah, that'll be what we'll do. All right, cool. Cool. So we're going to talk about variables and conditionals. Variables being, those wonderful little containers that hold values that allow us to do dry programming, right? Do you guys know what dry programming means? Dry means don't repeat yourself. So this wonderful note, right? All 12 weeks will be this style of note. And you'll notice there's some cool little things in this note. One are these neat little pop-outs. Whenever you see these little info icon, if you hover over top of them, it will pop out and give you some more information. Sometimes there's lots of information, sometimes just a little bit. Like, for example, this one says dry means don't repeat yourself. Let me see if I can zoom in a little bit, because it is difficult to see. There we go. I just don't want to... I mean, can you see that okay? It's back there that would be actually back here would be the worst. Can you guys see that okay? I mean, you got it in front of you anyways, right? You're going to read it in front of you either way, but trying to accommodate. All right, and on the other side, I will definitely zoom in for you on this side as well. We're not going to work in the index file today. We don't really need to. There is one thing I will point out inside the index file, though, and that is how we're able to get our JavaScript to actually interact with our page. And the way we're doing that is we have to include our JavaScript file inside our HTML page. Now, you guys have worked with external style sheets, right? Like you actually wrote your style sheet in another file and then you had to include it, right? Yeah, that's what I thought. JavaScript, not any different. You put the JavaScript in another file and then you include it into your HTML page just like you do with style sheets. Up here, you can see I've included a style sheet. I use the link tag. I tell it where the style sheet is under the href. With scripts, or JavaScript, it's a lot easier. I always put my JavaScript at the bottom, inside the body tag. So if you scroll all the way to the bottom, you'll see all of our JavaScript. And I chunk it in a few different blocks. There's third-party JavaScript, which is not mine, not yours. It's like Bootstrap, or it's Font Awesome, or it's jQuery. So like jQuery is in here if you ever want to play around with it, but it's really only in there because it's a dependency for Bootstrap. If you scroll down though, there's Prism. Prism is what is giving us this cool IDE looking kind of block. Prism allows me to actually create these wonderful little code blocks in whatever language I choose, whether it's JavaScript, C++, Ruby, Python, Fortran, Cobalt, doesn't matter. I can code whatever I want and it will actually highlight it for me. That's the end of our third parties for the most part. I do include one file of my own that I use that provides me a library for doing lab evaluations. And then there's your JavaScript. So this is the file we're going to be working with, the main.js file. This is the file where you will actually put your code, and that is how it's included into our web page. Next week, we'll actually work together, and we'll include it ourselves all together as a team, and we'll put the file into the HTML page. Down here is the evaluation code, which is the little test that I run against the code that evaluates the code and produces the answer. If you look at it, it's currently gzipped, but if you wanted to actually see how I did it, you're welcome to look at the master GitHub link, and you can see how the evaluation code is built. That evaluation library will be evolving, though. Right now, it's very prototype. I'm going to make it a lot better. I was going to just use a testing library like Jest, but because we're working on the client, and I don't want you guys to have to install Node, I decided to take a very simple approach to it. All right, so yeah, so this is us, this block here. It even says your JS. All right, my gift to you. So if you open up your IDE on the left side, you'll see a main.js file there. That's the file we're going to work in as we go through our note. Yours probably doesn't say greeting LAJSDJFJ. Does it say that? Yeah, I was kind of showing off to somebody. I wonder if there's any other stuff in here. No. Yeah, I was showing my test library to somebody at work, and I guess I pushed that up to GitHub. So feel free to remove that and save it, because it's not quite what we want. All right, like I said, let's talk about variables. What is a variable, right? It's a recap. You guys should already know what variables are. Variables are essential to the whole idea of dry programming. In the simplest terms, they're containers, right? Just like Tupperware containers that hold a value inside of them. The cool thing about a variable, the whole reason why we use variables is because hard coding data throughout our application doesn't make it maintainable, right? It doesn't make it very dry. It doesn't make it very modular, because it means that if that data changes at any point, we have to go to every location where we hard-coded that piece of data and manually change it. Whereas if we have a variable, and the variable has the data, all we ever have to do is change the value of the variable to affect every other location where it's referenced. Variables, incidentally, are also known as symbol names. So are function names. They're also symbol names as well. Class names are symbol names. Those wonderful labels you give these things, those are called symbol names, right? And you can create your own symbol name. And the power of that is being able to create a readable label that gives your data some sort of categorization, right? Some sort of explanation through that symbol name. That being said, that is one of my biggest pet peeves, is the whole idea of this. I hate this. This doesn't mean anything. This means something right here. This means absolute crap when I'm 6 files in and trying to figure out what n is. I don't know n has anything to do with this. This is much better. It's more verbose. It tells me something about the variable. It's easier for me to look at without having to backtrack through code to go figure out what this thing's supposed to be, right? So I definitely recommend clarity over compact, okay? The other thing that is important to understand is when the interpreter is going through your code anyways, all of your symbol names are getting stripped out and replaced with memory addresses so it can actually allocate your value to whatever the code is. So you're not saving anything by doing this anyways. All you're doing is making your code a lot less readable. So I definitely recommend readable over compression, okay? So that's just a little bit of a share. So, like I just said, these symbol names, they actually reference something. They reference a point in memory. On your RAM, it actually points to a specific point in your RAM that says, hey, this is where my value is located. But you don't want to pass around 0x12df everywhere because that's not readable. That's just about as bad as typing n. You want something that is human readable. So most programming languages give you the ability, every programming language gives you the ability, maybe not assembly, to be able to create a human readable alias for that memory allocation, right? And that makes things a lot easier to deal with when you're working with variables. So we're going to practice writing a variable. The first variable we're going to write is going to be very global, by the way. But we're going to write our first variable. And we're going to give it the symbol name greeting. And all we do in JavaScript is type greeting. We don't need a data type in front of it. We don't need to state that it's a string. We don't need to state that it's Boolean or anything else because JavaScript is going to take a look at our data value. And it's going to say, cool, that's a string. I know it's a string because your data value is a string. So it implicitly defines the data type on runtime. Just automatically knows as it's interpreting. So let's do equals, right? That's the classic assignment operator when we want to actually assign a value to a variable. This is no different than any other language that I can think of off the top of my head. Now, I'm not a Java programmer, so maybe it is different in Java. I doubt it, though. And then let's type in hello world. You can literally type whatever dirty words you want in there. It doesn't matter as long as you type a string. Okay, so let's do hello world. And then we're going to terminate with a semicolon. Now, ES5 and ES6 introduce the ability to not terminate with semicolons. However, I find that we wind up in a world of hurt because there's times that you have to terminate with a semicolon. So I would rather just avoid the whole problem and have you always terminate with a semicolon. Okay? So you can terminate with a semicolon. Plus, that should seem familiar, right? I mean, you have to use semicolons in Java, don't you? If it's terminating an expression? Yeah. So there you go. And if you did it correctly, our wonderful interactive page, you'll have to refresh. Mine does it automatically. But we'll update with greeting equals hello world. So just refresh your browser and you should see greeting equals hello world. Now, here's how this wonderful system works. If you didn't type in hello world like that, and instead you forgot these wonderful quote characters that define that this is a string, it will pop up and say greeting is not defined, which means you have an error. Something's wrong with what you've done. I find that most times people forget quote characters, JavaScript supports 3 different types of quote characters. It supports single quotes, right? Very classic. People are used to single quotes. It supports double quotes, right? And you may be curious, is there any difference between the two? And the answer to that is no. Not in JavaScript. There is no difference between the two. Double quotes is not going to give you any extra performance over single quotes. There's no difference between those two. However, the next one I'm going to show you, there is a difference. The next one is backtick. And you can find backtick right below your escape key on your keyboard. It shares occupants with the tilde. Tilde is a little curly thing, right? Backticks are freaking cool. Backticks allow us to do something called string interpolation, which is super, super cool, which we're going to take a look at in 3 weeks, actually. But basically, it allows us to put expressions directly within our string without having to concatenate or anything like that. We can just literally write it right directly in the string itself. So backticks are cool. We will be using them. But for today, let's just use the classic, nice, unique, elegant double quotes. All right. Data types. As I said, variables in JavaScript are implicitly typed, which means it takes a look at the value and automatically assumes what the data type is going to be. That doesn't mean that values don't have data type, right? They do. They do have a type. They do belong to a data type. And that's important, right? Especially when you want to do normalization, security, or maintainability or synchronization. You need data types, right? Because, I mean, users. God, users. Users will give you everything under the sun. If you ask for a name, they will type 5. That is what they do. These are the way these people work. So you need to be able to sanitize data and understand what that data is. Now, in most languages, you have a variety of data types available to you. You have, character and string, right? Car is different than string. Car is usually a singular character. String, depending on the language you're working with, is Java's got string as a data type? It's like a native data type. It is. You don't have to include a library for it. Yeah, see, in C++, you have to actually include a library because string is not a native data type. Character is. String is a character array. So they're different. But in JavaScript, we have string. We don't have character, though. If you want character, put one character between a set of quotes. That's your character. You don't have character. You've got string. You don't have integer, float, or double. You have number. It encompasses all of these wonderful things. They all get encompassed in number, okay? You do have Boolean, right? And that's true or false. Those are the two values that you have available to you. You have array. That is a data type. And you have object. And a lot of you may have heard, everything in JavaScript is an object. Everything in JavaScript is an object. And that's not entirely incorrect, but it is slightly incorrect. And we will talk about that during our object class in 4 weeks. But yeah, object is a data type. And you will find it every so often when you try to take a look at the data type of a specific item. Strict languages like C++ and Java require you to explicitly declare the data type. However, JavaScript is a loosey-goosey, duck-typed language. You may be like, well, what the heck is duck-typed? Duck-type, if you hover over top of it, if it walks like a duck and quacks like a duck, then it must be a duck. Right? That's JavaScript in a nutshell, because if it looks like a string, if it behaves like a string, well, it must be a string. That's just the way it works. That means it's implied. That's what implied means, right? It means I don't have to guess. I don't have to, state what it is. It's implied. All right. Our variable greeting doesn't have an explicit date type, but we know what data type it is. What data type is it, folks? String. Exactly. It's a string. And we know that because the JavaScript interpreter says, hey, I'm going to follow the duck type rule. Looks like a string, behaves like a string, must be a string. These are the available data types inside JavaScript. This table is fantastic, especially when you're having your open book, open internet test. This table is definitely handy to have around. Now, like I said, and I'm going to reiterate, the data type number encompasses doubles, decimals, integers, unsigned ints, signed ints, whatever you want to call them. All those things get encompassed under number. And there's a little note there. Every so often, if you're a person that's like, yeah, this is pretty basic, I like to reach out to those people who like to think that this is very basic, and I write little kind of more in-depth things. So you'll see little notes in there, like this one, for example, which says JavaScript doesn't have a character data type like many other languages do. However, in some mid-level languages like C++, the string data type is actually a character array. Curiously, though, many string methods in JavaScript operate the same way as an array does. Kind of makes you think, right? That maybe strings in JavaScript are really just character arrays under the hood. Let's create some implicit variables. All right. So we're going to go to step 2 inside our main file. Create a variable with the symbol name full name. Now, let's talk about symbol labels here. Real super fast. Just like many, many programming languages that are out there, there are naming conventions, but there's also naming rules, things you're not allowed to do. Okay? Anybody tell me what's wrong with that particular variable name? Yeah. Yeah, exactly. We are not allowed to begin a variable with a number. We are totally welcome to put it at the end, or in the middle, or anywhere else, but the first character of a variable has to be an alpha character. Whether it's uppercase or lowercase, it must be an alpha character. That's not entirely true. In JavaScript, you can also begin a variable with an underscore. You can begin it with 2 underscores if you want to. That's totally fine. You can also begin a variable with a $sign, right? That's PHP though, but you can do that in JavaScript. You can begin it with a $sign. Convention in JavaScript is a little different. Convention in JavaScript is this type of format. Does anybody know what that type of format is called? Yeah, camel case, exactly. This is the common format for writing JavaScript variables. It is not the rule, it's just the common convention to write JavaScript variables. If you want to write more words than that, see, I got a bit lazy with my writing. You just capitalize each word as you go. Okay? JavaScript also doesn't support this. What's the problem there? Yeah, exactly. You are not allowed to use a dash, as well as you are not allowed to use a space. It doesn't support it. It will blow up. The only language that I've ever come across that allows dashes in the variable naming is Ruby. But I mean, in Ruby, you can also add an emoji as a variable name. Which, I mean, you really want to piss people off? Use smiley faces for variable names. All right, so let's write ours. One other thing. I'm being verbose and I'm being explicit here, right? Full name with a lowercase n is not the same as full name with an uppercase n. I mean, computers are the most literal things you're ever going to come across. They're not going to understand that well, I meant this. Computers are like, no, these things are not the same. Right? Full name with a lowercase n does not equal full name with an uppercase n. So if you write full name with a lowercase n equals, please write your name, not my name, makes more sense. I'm going to write my name. And you hit save, what is the error message? Right, and why is it not defined? Because it's not the same word, right, exactly. So to make it the same, we're going to capitalize N. And if you do that, then it should spit it out to say full name is equal to whatever your name is. I marked on Monday's labs, and at least 2 people wrote my name. So, which I always find funny. Step 3, create a variable with the symbol name age and assign it the value of your age. All right, you can lie if you so want to. That is totally fine. I'll be honest. I just hit 40 as of December. I mean, it's fantastic, right? Make sure you write 40 without quotes, because quotes are a string. We want a number. If you write 40 in quotes, my error handling will say, age is not of type number. It is of type string, meaning I want a number, not a string. There we go. Now, hourly income is not defined either. And again, you can lie, make up however much you want. I'm going to say my hourly income equal to lots of money. And 34 cents. You can put a normal number in there as well, like a whole number. Doesn't have to be a decimal if you don't want it to be. That's totally fine. But it does have to be a number. Okay? I think you can even use negative. I think that might be okay as well. Yep, you can totally use negative as well. Maybe every hour you're alive, you're costing your parents a ridiculous amount of money, or costing yourselves a ridiculous amount of money. Step 5, create a variable with the symbol name married and assign it. There we go. That one's got to be a Boolean. Don't wrap it in quotes. Don't write 0, because I think not type Boolean is of type number, so it doesn't work. Don't write 1. Write true or false. Cool. Now, most times when we hit these questions, I'll give you a couple of minutes to fill them out yourselves. Okay? Right now, I'm just kind of showing you more how the application works. We're going to talk about variable scope, which is pretty important because right now, all these variables, they're scoped to something that's not so good, right? It's the classic, we shouldn't scope this way. Does anybody know what variable scope these are currently at?
Global.
Yeah, they're global. And global, is it good? No. Do you know why it's not good?
Because it's kind of public, so...
Kinda. Well, everything we're doing in JavaScript is public. They just right-click and look at the source. So everything's pretty public. But you are on the right track. It's also a pain in the butt to maintain, right? Because if I have a global variable, I've basically said, this variable I have created, let's say I call it name, right, is equal to Sean. And then I'm going to reference it through like 16 files. Well, I've just stolen that word from any other developer going forward. They are no longer allowed to use that symbol name, or they'll wind up with a symbol collision, right? They'll wind up with a reference error. They'll wind up with some issue because I've hijacked name and made it a global variable. Or even worse, they will use it. They'll reassign it. And everything will go south in my app, right? Global variables, not so good. Singletons, not nearly as bad. But global variables are not always good. There's better ways to deal with global variableness. That's a word I think variableness actually exists. But so variable scope, for those of you that don't know, is the visibility of a variable to the scope of an application that we're currently working in. Don't confuse these with class visibilities. Okay? These are not private, protected, and public. This is not the same thing, right? This is about variable scope. You guys know when you define a variable within a class or define a variable within a function, that variable is not accessible outside that function, is it? It's completely not visible outside the function. That is variable scope. That's exactly what variable scope is. In JavaScript, we actually have these modifiers we can use that define variable scope right at interpretation, right? And they are global, where there's no modifier. It's just automatically assumed that it's completely global. var, I imagine many of you have heard of var. var is functionally scoped, which means that if I define my variable within a function with var, it is only accessible within that function, okay? We also have block scopes, which are let and const, okay? So the difference between a block and a function, right, in JavaScript starts with the word function. This is the keyword that basically says this thing is a function, okay? Let's call it my func. There we go. And a variable, when it's functionally scoped, see this wonderful thing right here, this curly brace, right? What's happening here is var is saying, I am only accessible within this block, this function. I can only be accessed within this function call. However, say I have an if condition, right? We'll just pretend there's a condition in there. And I write var me equals 40. var me is accessible out here, well, not out here actually, out here though. It's accessible out here, it's accessible in here, it's accessible everywhere. Because if, is it a function? No, it's an if structure, right? It's totally different. It's not a function. Block scope works a little different. Block scope variables start with let or const, and they do mean something different. Block scope means I am only visible between this curly brace and this curly brace, or, in the if condition, this curly brace and this curly brace. Basically, I am only visible within the block. That's cool. That's actually really powerful, because now I can use my name variable wherever I want, as long as I'm between the curly braces and I don't try to overwrite it within that set of curly braces. I'm totally cool, right? Because it's only scoped within the block. Now, obviously, an example makes this a lot easier to understand. I do find that this is one of the more confusing subjects in JavaScript to people. So we are definitely going to beat this to death. So, step 6, create a variable with the symbol name favorite food and assign it to the string value of your favorite food. Give it only block scoped visibility and make it mutable. So, block scopes that we have available to us are let and const. Does anybody want to take a guess at which one's not mutable? Yeah.
That'd be const.
It'd be const, right? Because constants. Immutable means can't be changed. You can't change it. So mutable is obviously the opposite to that, which means you can change it, right? Const is short for constant, right? You guys have seen constants. Every language supports constants, right? Const is immutable values, things that you don't want to shift or change. Let is mutable, which means you can change them. So this says we need to make it mutable. So does anybody want to take a guess at which one of the visibility modifiers we're going to use? Let. Exactly. We're going to use let. Fave food equal cheesecake. I think I used cheesecake on Monday too, but I do like cheesecake. I don't like the hard cheesecakes. I like the whipped cheesecake. They're good. The hard cheesecakes are kind of right? But whipped cheesecake, that's good stuff. All right, step 7. Create a variable with the symbol name favorite color, or fave color, right? Because favorite color and fave color are not the same thing. and assign it to the string value of your favorite color. Give it only functional scope. Ooh, there's the catch. Give it only functional scope and make it mutable. Which one of our visibility scopes is functional? Nope. Well, let is technically only scoped within the function, but that's because it's block scoped. But there's one that's specific to functional scope. Var, yeah, var. Fave color equals steel blue. Now this handy thing will tell you if you use the wrong one. If you were to change var to let, it will tell you that it's incorrect. Which I might add was a very, very hard thing to do to get it to figure that out. All right, step 8. Create a variable with the symbol name DOB, which stands for date of birth, okay? And assign it to the string value of your birthday. Give it only block scoped visibility, and because your date of birth is not going to change, make it immutable, which means it can't be changed. Right? So which one are we going to use? Const, exactly. And then the last one, create a variable with the symbol name favenum and assign it the number value of your favorite number. Give it only global visibility and make it mutable. And I'll let you guys do that one. Give you a couple minutes here. Keep in mind, you don't want to wrap that in quote characters, right? Because it wants to be a number type. And pay attention to the error message that shows up if you get it incorrect. All right. So what visibility scope am I going to use? None. Right? Not a 1. Favenum equals, my favorite number is 256. And if you did it correctly, it should show. Now, incidentally, because it is literally impossible without parsing every single one of your files to tell whether or not you use var or global, you can put var in front of that and it will still work. But it is technically wrong. Var would technically be globally accessible within that file, but because it is functionally scoped, it's within the function that is wrapping our application that you can't visually see. Okay? Whereas global, it doesn't matter where you define global. If you define a global variable within a function, if you define a global variable within an if condition, it immediately becomes available to the entire application. That's why globals can be very bad. Okay? So just keep that in mind. Now, variables in JavaScript can also be instantiated without assigning a value, just like you can in Java, just like you can in C++ or a lot of really strict languages. You can't do that in PHP, though, and you can't do it in Ruby. They do require the value be assigned to it at runtime. However, JavaScript, you totally can. All you have to do is type your variable name with a semicolon, okay? Put your modifier in front of it, right? Now, if you want to have multiple, and you don't want to put them on, an individual new line each time, you don't have to. What you can do, let me just clear this stuff off the board here. What you can do is go your visibility modifier, and just comma separate your variable names. That's totally doable as well. Now these are all declared, they're instantiated, ready to go, but they haven't had an assignment yet. They won't be actually, well, they'll be usable right off the bat, but they'll all be undefined. But you won't be able to do much with them until you assign a value to them. But quite often we want to, set up some variables that we're going to use afterwards, that we're going to set afterwards, especially if we're assigning the value from an external source, like a user or an API or some other external source, right? Cool. That is variables in a nutshell. Any questions about variables? Pretty straightforward? Yeah? What about the variable scoping? Is that a bit confusing? No? There's a handy table, right? Remember, open book, open internet. I mean, it doesn't get more fantastic than that, right? These little notes you're free to pull up and look at any point. Okay? All right. The next recap we're going to talk about is conditionals. Conditionals, right? It's kind of a bizarre word, but really what we're looking at is condition syntax structures like ifs, if else if, switch, and my very favorite, the ternary. Right? We're going to look at all three of those. We might have a few seconds to actually look at some cool things you can do in JavaScript as well with comparison operators. So comparison operators, you kind of need to know what comparison operators are before you actually start writing if conditions or switch statements or anything else. Well, not really switch statements, but because you need to know how two values or expressions are compared against each other. So comparison operators basically allow us to test two values against each other. Comparison operators compare at a binary level. Not sure if you knew that. Which means A is greater than capital B is false. Because capital B, according to the binary version of it, right, because it goes by the ASCII table, picks up its actual number value, and then assesses that number value in binary, is higher than lowercase a. That just happens to be the way it is. So you need to understand that it's always done at the binary level, which means you're not restricted to just comparing numbers. You can actually compare letters, you can compare names, you can even compare Booleans, right? Which are technically just 0 and 1 in binary, right? The following operators are the most common comparison operators you will encounter as a programmer in programming languages. Now, we're not going to look at XOR or NOR, right? We're just going to look at these ones. Logical operators, which are the double ampersand or the double or, right? There are also other ways to write those. There's and. You can write it in lowercase. Or you can use, this is always such a pain to write. Haha. I mean, that's not half bad, right? It's pretty close. There's also or the double pipes, right? So there's also, those are logical operators, and or. And what they're generally used for is to take one expression and compare it against another expression, right? And then it has to evaluate to true. So there's a wonderful handy table here that has comparison and logical operators on it. The first set is comparison operators, the second set is logical operators. So is equal to is just a double equal sign. And in JavaScript, that loosely compares two values against each other. So interestingly enough, in JavaScript, 5 is equal to the string 5. They are completely equal to each other. That is a valid operation. And you can test that if you open up your wonderful console. I'm going to zoom in for you. Scroll to the very bottom. I'm also going to clear it for you. And I'll show you. 5 is equal to 5. And that is equal to true. Okay? And that's because of loose comparison. Essentially what is happening is JavaScript's like, cool, we don't want to pay attention to the data type here. We don't care what the data type is. We just want to say, hey, 5 and 5, well, they're both 5, right? So they obviously are equal to each other. Okay? That is not reliable, though, and it's actually recommended not to use the double equal sign. It is recommended to use the much more strict triple equal sign, which you will notice says false. And the reason why is because 5 is not equal to string 5. 5 is a number, not just a value. Basically, the triple equals sign compares not only the value, but it also compares the data type. Okay? So for the most part, we will always be using the triple equals sign because that is the common convention. There's also not equals to, the loose version, and not equals to, the strict version. The strict version of not equals to is the exclamation operator and 2 equals signs. And it says this value is not equal to this value. And both of their data types are the same or not equal to each other. We have less than, we have greater than, which looks like I wrote it wrong. We have less than equals, and we have greater than equals, which is also written wrong. But the example shows the correct version of it. I will correct those, though. Then we have the double ampersand, which allows us to take 2 expressions and evaluate them. So what we're essentially evaluating, though, is whether or not both expressions are true if we're using the ampersands. Right? So if I want to see if these 2 expressions are true, so 5 is greater than 1, right? God, I hate writing these things. It's like trying to program your muscles to work in a way they're not used to working. And then 20 is less than 100, right? Is this statement true or false? It's true, right? It's true. And the reason why it's true is because this evaluates to true. 5 is greater than 1, right? This evaluates to true. 20 is less than 100. And this says, hey, this needs to be true, and this needs to be true. And as long as both of those statements are true, then the whole expression evaluates to true. Now, if we swap this out, and we write our OR, and let's change this wonderful operator to a greater than symbol, right? Cool. Is this false or true?
True.
True. That is exactly it. This evaluates to true. This evaluates to what? False. Exactly. This evaluates to false. But this OR operator that's in the middle says either this is true or this is true. But one of them has to be true. That's all that matters. As long as one of these two is true, then the whole expression is true, right? Is this new for anybody? No, you guys did this, right? Cool. So let's write some, just for extra practice. We'll fill out our QWERTY variables here. All right. The first one says, compare 5 and 5 so it is true. Remember, that's what type of comparison do we have to do there? Loose or strict? 5 and 5 are true. Loose, exactly. So we need loose comparison here. So we're going to say let Q equal to 5 equals 5. And if you did it correctly, it will say the expression. Compare 7 and 3 so it's true using the greater than symbol. So I'll give you a minute to just write that one. Cool, hard 60 seconds. Clear this silly thing off the board. Okay. So, equals 7, 3. What operator am I going to use in the middle? Greater than symbol, right? Cool. And if you did it correctly, I should say that. Compare Sean and Bob so it is true using loose comparison. All right, this time we can't just say equals equals because that's not going to work because even though Sean and Bob are technically the same data type, they are not the same value by any means, right? So what operator am I going to need in the middle? Remember, it's loose comparison. Not equals, yeah. There we go, which is the exclamation and the equal sign. Step 13, compare 5 and 5 so it is false using strict comparison. Right? Strict comparison would be 1, 2, and 3, right? Yeah. 5. And if that is correct, you should see it on the board. Cool. 2 more to complete our QWERTY. Step 14, compare both expressions so it is true. So I've given you 2 expressions here. All you need to do is assign the evaluation of those 2 expressions to t. So there's only 2 logical operators that you're going to work with because we're not talking about XOR. We're talking about double ampersands and double equal sign, or sorry, the 2 ampersands or the OR characters, right? The pipe characters. So start off with your equal sign. All you need to do is use the variables, right? You don't need to write the expressions all over again. And you can if you really want to. But what logical operator goes there? What do you think? Yep, double ampersands and if you did it correctly, it should say it. I mean, I think even OR would work there actually, because yeah, that would actually make sense that it would work there too. Because then you're just comparing Boolean to Boolean, essentially. Some of these are actually hard to evaluate because the evaluation can't actually evaluate syntax, unfortunately. So I have to do little tricks to try to get it to work. And then let y equal, right? Again, we're going to compare these 2. So EXPB1 and EXPB2. Yep, and it's going to be the OR sign. Exactly. And I imagine not equals would work as well. Cool. I mean, this is all leading up to the fact that understanding how comparison operators work makes life much easier when you're going to do evaluations with if conditionals. So let's do that now. So we're going if, else if conditions. Okay, before I do that, do we need another break or do we want to just rock it through and then end early? Okay, yeah, I agree. Let's just rock it through and end early. All right. So step 16, write a condition that accomplishes the following logic. So there's 3 steps to this logic. You can't break them up, unfortunately, because if you put spaces between the if and else if, it will actually disrupt the connection and cause a problem. You'll get a syntax error. So you need to write them underneath. But we can do them in steps. So the first one is if our test num is greater than 10, set it to 10. So this is an if condition, and this is how the syntax looks. If, we use a set of parentheses. These, you can think of them almost like a function call, right? Think of if as if it was a function. And this block right here, this little thing right here, is where you would put your argument. Your argument is the expression that you want to actually evaluate. The expression we want to evaluate is our test num. And we're basically checking to see, is it greater than 10? So we're going to say our test num, if I can type, greater than 10. So we're going to put our expression in there. At the end of the day, the if is only looking for one of 2 values. Does anybody know what those 2 values are? Yeah.
Like for this specific example, or
any if condition is always looking for only 2 values.
Whether a condition is fulfilled or not.
Right, but there's two values that can possibly be. True or false, exactly. And it will only execute the block if it's what?
True.
Yeah. Does it matter if you use a not operator? Does that change that logic? No. All it does is say, if it's not false, which is still true. That's basically what happens. You're always evaluating true. It will only execute the block if it's true. If you pass it false, it will fail and not execute the block. It will move on to whatever is after the block. So we're testing to see if our test num is greater than 10. We'll give it a block. If it is, then we're going to set it to 10. So we're going to say our test num equals 10. Otherwise,
Else.
nope. Read the whole statement. Otherwise, if our test num is less than 10, set it. So it's not else. What is it? Else if. There we go. I mean, I didn't want to shatter your dreams. You were so eager about it too. But yeah.
No, it's funny because I have else if in my computer.
So now we just need to write the expression in here to evaluate, which is our test num. And what is our evaluation? What operator are we going to use?
Less than.
Yeah, less than 10. Yeah. And we're going to set it to 20. Our test num equals,
And then you do else.
and then it's else. Yep. And this basically means, what else basically means is, hey, if this condition doesn't apply, then check this condition. If this condition doesn't apply, don't just move on. I have a default that I want you to do. I have this thing that I want you to do as a fallback if the other two conditions don't work out. And in this condition, we're going to say our test num is equal to 15. Which means if our test num doesn't evaluate 10 or greater than 10, cool, we're going to try to see if it's less than 10. If it's not less than 10, then we're going to say, cool, just make it 15. Does anybody want to guess what that will outcome? Like, what will be the value of our test num at the end of that? How many of you say 10? How many say 15? Okay. How many say 20? No? Okay. Can't tell if there's only like 3 participants or if it's legit. All right. Cool. I'll leave you alone. Let's move on to switches.
So what's it gonna be?
It's 15.
Should be 10.
Why?
On my console it shows 10.
What?
I don't know.
Can't. First of all, is it greater than 10?
No.
No. So we're not going to set it to 10. So no matter what, it can't be 10. Is it less than 10?
It's not, but like it's curious, why would it show 10 on my console?
Did you spit out our test num? Is that what you spit out in the console?
I just put the statement in the console.
Here. Let's open it up. Did you make sure that you copied this as well? Actually, you don't need to copy that because it should already be defined. That's weird. Hold on. Our test num. No, that's not even possible. If our test num is greater than 10, which it's not, it'll be equal to 10. If our test num is less than 10, then it should be equal to 20.
We have to say that it's 10, then it will show that it's 15. Otherwise, it will show 10. First, we have to define that it's what test num is 10, and then you have to just do the condition if it fails.
Yeah.
It will show 15.
Right. Okay. Yeah. So it's evaluating, it's failing. It evaluates and sets, it fails. Evaluates and sets. No, it's still weird.
And you thought I was joking.
Yeah, I thought you were joking. Let's try it with the switch statement, because the switch statement works a little better. That doesn't make any sense, though. That's going to bug me. That's definitely going to keep me awake. I mean, it doesn't work. It just does not work. Less than or equals to would totally work. Then I could see it, like, entirely. But let's move on to the switch statement. All right, so a switch statement. Have you guys used switch statements? Has anybody not used a switch statement before? No? Do you have switch statements in Java? You must, right? Yeah, you guys did switch statements in Java? All right, so do switch statements in JavaScript Java use case?
Yeah.
Okay. Because Ruby uses when, which is bizarre. Python uses something weird too. When.
Oh yeah.
Yeah, so you initiate your switch statement with case, and then all of your cases are when.
Really?
And then when you want your default, it's else. Yeah.
Actually makes sense.
By the way, for the other thing, I refreshed my page and I got 15, so it doesn't work.
So it does work.
I think you just need to refresh the page.
That's quite possible.
Mine shows 15.
Yeah. Refresh your page. It does equal 15. It looks like it's a caching issue. Now I can sleep soundly. Yeah, that's correct. I mean, in all honesty, I was going to sleep soundly. Right? Sleep like a baby. All right. So a switch statement evaluates an expression, then performs an operation on it based on the expression's value. Right? So switch statements are very cool conditional structures. A lot of people use them more for readability because it's a little easier to read than constant if, else if, else if, else if, else if, right? Switches are a little bit clearer. But that's not the only power of a switch statement. Switch statements also have the ability to modify data constantly, right? So if it evaluates in the first case and then meets the second case, you can do more operations on it. And then you can have it meet the third case, and it will do more operations. So you can use it to constantly modify and mutate data as it goes through the cases and then spits out at the other end in some sort of format. Basically like using it like a factory, yeah. If you don't put break, exactly. If you don't use break, that's how you can perform that operation. Switches in JavaScript are really, really powerful too because this just needs to be an expression, just needs to be a value. That value can be anything. It can be a number, it can be a string, but it can also be a Boolean value, which means you can say switch true, and then put conditional expressions as your case evaluations, which is pretty neat. And there's times where you will actually do that. So switch statements are made up of various pieces of syntax, and I thought the best way to go through and make this easy to understand was to use those pop-outs. So if you scroll down a little bit and you hover over each of the words, they actually tell you what they do and what they mean. So switch is the command that tells the interpreter that we want to evaluate the following expression or variable and execute the logic. So this is the argument that we're passing to it that can be the variable or expression or literal value that we want to pass in. Case basically says, hey, if this is equal to this, then execute this block. Okay? So we're saying if service equals terrible, then set tip to 0 cents is what we're basically doing. Then we have the break. The break says once you have finished executing whatever expressions are in this block, then exit. Exit out of the whole switch and move on with your life. Okay? Breaks are optional. You don't have to put the break in. The problem is, though, if you don't put the break in, it will then evaluate the switch statement against bad. Then it will evaluate it against bad. And then it will evaluate it against good. And then it will evaluate against default, which will execute at all times. Default basically says, if none of these cases are okay, right? Which actually doesn't even say that. Basically it says, execute this if you make it down to here, is really what it's saying. So if you forget your break statements, it will hit this default every time. Now, that might seem like a bit of a glitch, and oh my god, well I forgot my break statement, but there are times where you may want this to be a scenario, right? Because it actually evaluates this even if the value changes. So, for example,
Say you hit case terrible, and then you set service to equal bad, and you forget your break statement. The next case will evaluate service against bad, which you just changed it to, and it'll be like, cool, I'm going to execute this statement. And you can continually do that.
Switches are extremely, extremely powerful, but can be confusing to people. All right, so that's our basic switch. So we're going to write one. We're going to write a very simple one. We're going to say, if res is equal to 10, then set res to 15. Otherwise, if it's equal to 15, we're going to set it to 20. Otherwise, it should be set to 30. So the first piece that we need is the actual switch command. And what's the variable or expression or value that I'm going to give the switch? Res, exactly. We're going to give it res. Then we're going to add the block onto it. Incidentally, if you set a variable in here with let, it is scoped only to the switch block. If you set the variable inside a case statement, it is scoped to just the case statement. Just so you're aware. All right. So the first one we want to check is to see if it's equal to 10. Now, it's important to understand that cases are evaluated strictly equals. And what that basically means is, in the background, essentially what's happening is this. If res equals 10. That's essentially what's happening in the background under the hood. Does this thing strictly equal 10? Okay? So if it is equal to 10, then we are going to blah, 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 set res equal to 15. And then we want to break, yeah. Now you don't have to just break. There's another option besides break. Some people don't break, they return. That is also an option. You can return. Case 15. Res. If it's equal to 15, then we're going to set it to 20. And we're going to break. Otherwise, res should be set to 30. So what do I use if it's just our, default? If it's our default operation, we use default. Res equals 30. And break. Now, I'm going to refresh this time so that this actually works properly. And clear it. What is the value of res? How many people say 30? How many people say 20? And how many people say 15? Cool. Let's check. And it's 15. Now, let's...
I don't like this. I'm done for the day.
Can you put break?
Maybe you missed a break.
Yeah,
So let's make that test though. Let's take the break statements out. What is the value of res now? Some people say 20. How many people say 30? How many people say 20? How many people say 15 still? Okay. Res is 30. And the reason is because the first time we go through the case statement, our res is 10. And then we just changed it to 15. And like I said, it always evaluates against the value, whether it's updated or changed or not. It's relevant. We'll evaluate against it again. So now, res is 15. Case 15. That's true. So now we're going to set it to 20. Then, because there's no break statement here, we will definitely hit the default. We will go through the default whether we like it or not, regardless of whatever these values have changed to, which means we will set res to 30 and then exit. Cool. So a common algorithm you may see is the evaluation against true. Because like I said, one limitation to switch is that you can only strictly evaluate against. Right? So when you set a case, it is always strictly evaluated that it's equal to whatever the variable is. So a way around that, and the way to use switches with any kind of condition, is to instead give the switch the value of true. If you give the switch the value of true, you can now put expressions inside the case and say evaluate this expression against true. Works just kind of like an if condition. You can also do the opposite. You can give the switch a false, and then now evaluate every expression to see if it is falsy. Right? Makes them very, very powerful. By the way, notice a little tip underneath that. I tend to put the above logic on tests, so I recommend keeping track of that one. I like people to think outside the box a little. All right, we're at the very end of this. Yeah? You all look like you really need to be at the end of this. Yeah, you just have evaluations not happening the way they should.
I mean, like, they work. They're not like, say, it's not saying like you're doing it wrong, but like,
Right.
it's giving you the wrong answer. Or the right answer.
All right, we're going to talk about probably one of my favorite shorthands. One of them. I have a few that I like. Or equals. Or equals is probably one of my favorite. That's this one. That is a very cool operator. I don't know if it's available in JavaScript, but it's available in Ruby. I'll explain it in a minute. But anyways, we'll talk about the ternary, right? Have you guys all, has anybody never written a ternary before?
I know what it is, but it's so hard. It's confusing.
Oh, okay. Well, hopefully we make it simple. Ternary statements are one-liner if conditions, essentially. They are literally an if-else. That's what they are, but they're in one line, right? And they return a value for the true or the false, okay? They will return one or the other. So if your condition is true, then you will get the value for true. If it is false, then you will get the value for false. The most common place that you will see ternaries is in toggle logic. If we need to toggle back and forth between two values, ternaries are fantastic for this. And that's what we're actually going to build. We're going to build a light switch. But before we do that, you can see I have let age 40. And if you hover over these, it gives you some information about it. The syntax basically works out that you start with a condition, the condition you want to evaluate. It doesn't have to be within parentheses. That's just common convention because it makes it a lot easier to read when you wrap it in parentheses, but you don't have to wrap it in parentheses. The next piece you need is the first part of the ternary operator. There are two pieces to the ternary operator. There's the question mark, and then there's the colon. Those are the two pieces to the ternary operator. The question mark says, hey, I'm done writing my condition. That's what you're evaluating against. Does that equal true? If it does, it will return what is on the left side of the colon. Okay? So if it is true, so here we'll do question. If this is equal to true, it will return that. If it's false, it will return the right side
It's always true.
of the colon. What's that?
So it's always true first.
Always true first. Never changes. Unless you write this so this is like the opposite, right? If it's a not done. Yeah. Otherwise, it'll return this. So, age 40, what does age 40 return? Old? Yes. How many people say old? Yeah, cool. How many people say young out of curiosity? Yeah? No. All right, so yeah, it returns full. Basically, it says it is greater than or equal to 40, which 40 is equal to 40 last time I checked. Then it returns back old, because that is true. Otherwise, if it was less than 40, it will return back young. Okay? So let's write our ternary, and then I'll talk about nested ternaries. So we have our variable. It's set to light switch, and its current value is on. We want to turn it off if it's on, and on if it's off. So what we'll do is we will say light switch equals, because we want to return the value back to light switch, right? So that we can change it. And in here, we basically want to check to see if it is on. So we're going to say light switch equals 3 equals on. So if the light switch is equal to on, then what do I want to send back? Off. Otherwise, on. That will toggle our light switch. If you did it correctly, it should say light switch equals the whole ternary statement. Now, people fall in love with ternaries, and then they try to get super, super complex with ternaries, and they're like, if I can return on and off, can I not also just stick another ternary in here? Yes, you can. You can put another ternary in there. And then inside that ternary, you can add another ternary. And you can keep writing ternaries till you run out of RAM, right? The problem is, what is the biggest problem with that? Oh yeah, hell yeah, it's totally confusing. You lose readability, and readability in programming, to me, is like the most important thing. You've reached like programming guru status when you don't need to write a comment in your programming because your programming is so readable that you don't need tons of comments in order to explain it. That's why I love Ruby. Ruby is one of my favorite languages because Ruby is all about comprehension over convention. I should be able to take a Ruby script and read it without breaking my brain. It should make sense. It should read like English. That's why programming is written with English words, right? Because it should be able to be readable. You should be able to start at the beginning and read it to the end without and kind of get an idea of what's going on. So readability is very, very important. And you should always be trying to push for that. Trying to always adopt better readability over convoluted, shortcuts, right? That being said, you're eventually going to want to start doing metaprogramming, and that just breaks everything altogether. But metaprogramming is a wholly different subject. Any questions about conditionals? Any questions about variables? No? Okay. So that thing we just wrote is your lab. It's done. It's ready to go. So where do you submit it? If you go to Blackboard, and you go to weekly learning, and you go to the week that we're in, you'll see a shortcut for the Lab 1 submission, variables and conditions. Read what it says. It says, submit the main.js file you created during class to Lab 1. Do not compress it. Do not zip it up. Do not give me every file. If you click on it, there's a block here that says, upload just the main.js file. Do not zip it or you'll lose 5 points.
What?
Yes. Do not give me all the files or you'll lose 5 points. Basically, make my life a fucking pain in the ass and I'll keep deducting points. Do not give me a GitHub link or you lose 5 points. So if you want to totally tank it, give me a zipped GitHub link with every file and you'll totally tank it. Right? I'm pretty good. I'll probably just knock a couple points off. But don't zip it. Just be nice to me. Don't zip it. Give me the main.js.
Just because you told me not to.
But really, is it worth the points just to make All right. Cool. And then if you're we're done. I've got nothing else for you. So you could look at the Module 1 quiz and give it a go. You get 2 attempts. You can work in pairs on it. You can work in groups. All of you can do it at once if you want to. That's totally fine. What's not? It's not available?
It's not available under quizzes, but it's available under weekly learning.
It's under weekly learning.
Click on it says resource unavailable.
Yeah, it says item is not available.
There you go. That's stupid. I made it available in the one place, but it doesn't make it available immediately in the other place, which is it's a link to the same thing. It's stupid, but whatever. It's available now. So every week will be exactly like this. We'll be basically working through the note file, and you'll complete the lab during the class, and then you'll submit it. That'll be every week.